All thanks to our creator. Uh, Today we'll be talking about logarithm. In our last class, we have discussed about indices and standard form. So with we will continue for today's class to be logarithm. So logarithm uh, is about power. Can be another word for power. So what do I mean? For example, in our standard form, okay, logarithm. In our last class, when we are talking about standard form, I made mention that is 10,000. Sorry, 1,000 can be 10 raised power 3, or I said our points will be at the first figure. That will be 1.0 times. Let's move our point 1, 2, 3 times 10 raised power 3 is something as this. But this power is what can be called logarithm. In what terms? For example, if we are given a log 1000 base 10, it's b equals to 3. So how will it be equals to 3? It will be equals to 3 because this 3 here is what? Is the log of 1000 in base 10, meaning that if we were to work it in by using this formula of logarithm, one of the formula of logarithm, if we are given our y equals to n raised power x, our what? Then our log, then our x, which is the power, will be equal to what? Log y base n. Log y base n, meaning that if you are to look at our 1000 here, our 1000 here will be our x. Our 1000 here is equal to 10 raised to power 3. That will be our y. Our y equals to n raised to power x. Our x here, which is the 3 here, will be our x. Will stand alone, which is our 3 will stand alone here. Our y, which is the 1000 here, will be log 1000 log y base this the raised power, the one that has raised power, that's 10 log 10, the one that has raised power, that's log n. I hope it's clear. We can do it in another way as part of the laws of indices, meaning that if you have log x, log s base s will give us 1. Log s base s will give us 1. So how could we solve this? For example, now if you are given if the whole number and the base of the logarithm are the same, it will be equals to 1. Under laws of logarithm, which I will just briefly go into, is that if you have this one, if you have log x base x log s raised to power, maybe let's say y, so it will be equals to, we can transfer this y to the back of the log, which is equal to y equals y log x base x. So this y can come to be the power of this x, this whole number x, or to be at the back of the log. So the y has a free movement from moving to be the power of x back to what in the back of the log. Now let's now solve this using these two formulas. Here we are using log 1000 log 1000 base 10, and our 1000 can be, in standard form, can be what? Log 10 raised to power 3 base 10. By using this formula here, the power here to move the back of what? At back of the log. The power here, let's move it back of the log. That will be what? 3 log 10 base 10. So if we are to use this formula here, if the whole number and the base of the logarithm is equal, it will be equals to 1. So we can say log 10 base 10 is equal to 1, because both of them are 10, meaning that it will be equals to 1. That will be, so this will become 1. That will be 3 times 1, which is equal to 3. So we will get the same formula here, but this is what is the shorter form of it. So that's a bit introduction under logarithm. Under logarithm, there will be with the use of table and the one that involves without the use of table. So what we'll be doing in for today's class will be the use of table. So we'll be using the 4-figure table. So we are in we have been in a world in which most of uh, most of those who study mathematics are inclined to using calculators. Client using to calculator, attached being using calculator. Even if it's a simple arithmetic, there will be I would like to say they will be quick to use calculator instead of trying to use their brain even in a single arithmetic form. So that's why I would like to introduce the use of 4-figure table. That will be like that will be like using of 4-figure table have become a thing of the past. So I'll try to use the 4-figure table here so that we can be familiar with the uses of 4-figure table. So this is a 4-figure table here, a 4-figure table. So we have different kinds of mathematical tables here. So we have logarithm of numbers, the one we'll be using anti-log, natural log, square roots, and so on and so forth. So our main concern for today's class will be logarithm of numbers. Logarithm of numbers. There are also other logarithm, which are the logarithm of sine of angles, cosine of angles, tangent of angles. So if you are trying to find a logarithm, so you have to be careful of the one to use, because we are dealing with numbers here, not the one of the angles. So we'll be using what? Logarithm of numbers. So that's page 1. So that's page 1. I hope is a bit clearer here. So in logarithm of numbers, we have 3 sections when we are looking for our logarithm. The first one is what is the numbers here. The numbers here. The next one is what is the numbers, all the numbers that is under 0 to 9. That's the second one. While the third one is the difference here. So if we want to search for a number using a logarithm, using a table, we can what? Okay, let's first start with an example. For example now, an example. So with the use of table, with the use of table, with the use of table, find the logarithm, find the log of a 3.7, b 37, c 3700. We want to find the logarithm of these three numbers. To do so, we first need to know something here. The class of standard form will assist you greatly with this logarithm here. Firstly, our first one is what? 3.7. 3.7. Firstly, we have to notice where our point is. Our point is what? At the first of what? After the first figure here, which is 3. Meaning that if we are to convert this to standard form, we have what? The points won't move. That will be 3.7 times 10 raised power. Since the point doesn't move because that's the initial place where the point ought to be when what? When we are turning a figure numbers to standard form. That's the first after the first figure. So that will be what? 3.7, meaning that our point, if we have to convert this to standard form, our point won't move. So that will be 10 raised power 0. That's the 0 means what? The point at which the number of steps the points move. Whereas in this example here, the point doesn't move. So that means so what we will need here is what? Is our 0 here. Now the 0 here. So since our standard form of this is what? Is 3.7 times 10 raised to 0. So if we are to use our table here, our start from is 0 point. Is 0 point. Meaning that this 0, we got it for what? The use of standard form. Now we are looking for what? 30. We are looking for 3.7 in our logarithm of table. To find that, after calculating our standard form, to get our what? Our first digits before the point when looking for our table. So the next thing is that to ignore the decimal point in the question given to us. If we are to ignore our decimal points here, our decimal point in 3.7, we will be left with 37. By ignoring, we are just ignoring the decimal point temporarily, not permanently. So back to our table, we are finding for 37 from 3.7 while ignoring our decimal point which will be 37. So we are looking at, we'll start from our x because that's what we are looking for. The unknown we are looking for our x, so we are looking for what? Our 37. So these are our 37, these are 37. So it was be the logarithm of 37. The first one is what? 37 under 0. This under 0 we have 0 to 9. So under 0, 37 under 0 we have what? 5, 6, 8, 2. 5, 6, 8, 2. So let's write down 5, 6, 8, 2. So we'll start after the point. That will be 5, 6, 8, 2. So that's our what? Way of what? Solving for our 3.7. So the log of 3.7 will be what? Is 0.5682. Don't forget how we got our 0 by first changing the question to what, to standard form. So the power of the 10 will determine what we get here. So now let's go to the log of what, the log of what, 37. Firstly, let's first change our 37 to standard form. We have what, 3.7, meaning that our initial place in which our points, our decimal points has to be is what, after the first figure, that will be 3.7. So our points moves from the last figure here to the left hand side once. That will be times 10 raised to power times 10 raised to power sorry times 10 raised to power 1, because our points moves to the left hand side once. That will be 3.7 times 10 raised to power 1. Since we have gotten what's in the power of what we have the raised to power 10, that will be 1. So start our solving for our log of 37 to be what, 1 point, 1 point, the one we got here. So now if you have to look our log, the log for what, 37, there's no point here, so there's no need of saying want to ignore any decimal point here. So if you have to look for our points here, our log 37, which is the same as of what we find earlier, that will be 5682. 5682. We have 5682. So the difference between the first and the second one is what is before the point. We have 0 here. The reason why we got the 0 is what, is firstly converting our question to what, to standard form. That's why we got our 0 here. If you have to convert our standard form of 37, we have 3.7 times 3 raised to power 1, meaning that we have to start from 1 point. So let's move to the third one. We have 3700. Firstly, let's convert this to standard form. Move our point to start from the last figure here, since there's no decimal points within the number given to us. So we'll start our points from first write 3.7. So our points here, that if zeros are what, after the point, if zeros are after the point, it will be counted as nothing. If you have to check my last class on standard form, you understand better, but let's proceed. So 3.7. So let's count how many times our points move from the last figure to where our points supposed to be initially when dealing with standard form. That will be 1, 2, 3. So our points move thrice. So that will be 10 raised to power 3. Since our points move to the left hand side, so it will be plus 3. That's 3. Now back to solving for our logarithm of 3700. That will be, you start from 3 points. Now me looking for our standard form of this, we will look for 37. Since this one has zeros only, so there's no need to further look about it, or we can just say look for 37 under 0 difference 0. So these are logarithm. We are looking for 37 under 0. Yes, under difference 0. There's no 0 here, so it will be left like that. So 37 under 0, that will be 5682 again. 5682 again. That will be 3.5682. So that's how to look for the logarithm of a number. The logarithm of a number. So these 3 here are what is the integer that we got from the standard form, while all this one are what are the decimal fractions which we got from our table. So we can simply do a further what's it called, a further examples under logarithm. So we name, let's say this our example 1. So since if this is clear, I bet the next one should be clearer. So we have, maybe we are looking for the log, find the log of a, 37.4, b, we have 3.746. So our a, so we want to look for our 37, the log of 37.4. Firstly, the first thing to do is what, to convert this figure to what, to standard form. So our point is how to move what to be here after the first figure. That will be 3.74 times 10 raised to power. So how many times does the point move and which side? So our point move from here to the what, to the left hand side just once. So that will be 10 raised to power 1. So since we got our integer from the standard form, we have what, 1 point. 1 point, that's our integer. So the next thing is what, is find for the logarithm. So while ignoring this decimal point 7, we left with 374. So we are ignoring our decimal points temporarily to find for our standard form. So we'll be looking for 37 under 4. You know, in our previous examples here, we did only with 37 under 0. So here we're dealing with what, a new way. We are looking for 37 under 4. So so our 37 again, so we are looking for 37. These are 37 here under 4. This 1, 2, 3, these are 4. So trace it downward under 4. So this 37 under 4, 37 under 4. Our 37 under 4 is 5724. You see it's 37, 5729. 5729. You have to be careful when searching for what, the table. That's 5729. 5729. So that'll be 5729. So you see that's all. So you have to use your calculator to solve. You see that will get the same thing. But I prefer my students to try and use their brain, the four-figure table, while making the calculator the last option to use. It tries and sharpens the brain of my students when dealing with, when solving mathematics. And mathematics is a subject that is needed in almost all aspects of life. So why sharpening your brain without uh, without depending on calculator? Because there will be some exams where you be told not to use calculator, or when you want to solve a question you are not with your calculator and that stuff. So you need to try and sharpen your brain by not depending on calculator all the time when solving for arithmetic questions and also forth. So let's move to our second example, which is 3.746. 3.746. Now let's first change this to standard form. Since this is where our point is supposed to be, that will be 3.746 times 10 raised to power. Our point isn't moving at all, since that's where our point is supposed to be initially when dealing with standard form. So that will be 10 raised to power 0, because our point doesn't take any step. So we'll start our words solving for our 3.7 forces by knowing our integer to be 0 point. So now notice, but is this different from this and different from this? So we are looking for, so here if we want to use our table to solve for our logarithm, if we want to use our logarithm to solve for this, firstly we ignore our decimal point. As I said earlier, that will be, we will solve for what? 337 under 4 under difference 6. 37, this is our table. These are 37 under 4, which is 4 5 7 2 6. Firstly, let's first write that. Let's first write that one down. We got our 5. Let's write it somewhere. We got our 5 7 9 2 9. No, we stop at under 4. We are moving to under difference 6. So this is our 37 under 4. Now under difference, these are difference here, difference 6. So what's under difference 6? So let's trace it down. So this difference 6, which is 7, you see, that's, we got it. So that's 7. So that means this difference means that we have to add what it to what we got here. So we got 5 7 2 9 plus 7, the one we got under difference 6, that's 7. So if we have to add both together, that will be 7 plus 9, that will be 16. 1 will be added to this, so we have 5 7 3 6. So 5 7 3. So our answer of what is 0 0.5736, meaning that the difference, the meaning of this difference here means that we have to add it to what we got when we initially, after looking for our difference here. So our 37 under 4 give us 5729. When we look for our difference under the table, we have 7 there, so we have to add it to the 7. That will give us 5736. So if you are given a number which is which it has 4 figures like this, so look for the first 2 numbers figures will be for the table we are looking for. So the next one will be under the table, the last one will be the difference, under the difference given to us. So that's just how to solve it. So before we end today's class, I would like to give you some assignments on this. I'd like to give you some assignments on this. So I hope this is clear. So the assignments I will give you will be assignments. So our assignment is what? Is find the logarithm. Find the log of the following. Find the log of the following. We have A 75.12, B we have 4137, C we have 208.5, D we have 1.903, E we have 100.6. So we are looking at this. I hope it should be clear to solve it. So firstly, we change our what to get our integer of the table of the answer. Firstly, we first change each of them towards standard form. So the power we got will be determine our integer. Then we'll now find the table. We'll now look for our logarithm using the table while ignoring the decimal points. So that's all. So we'll meet in our next class. Take care.